Greetings. Let's start atomic structure. I'm here going to explain you all the needed points for your A-level exam. Other than these points, there will be no any other question they will be asked. So let us go through these points and then you can do any question under this subtopic. So here I start about atomic models. Let's go to question number 1. The ionizing power of alpha particles is greater than the ionizing power of beta particles. So this question has a certain exam point. That exam point is the comparison of alpha, beta, and gamma. The comparison. So let's discuss about the comparison. This is one exam point. This is the first exam point you need. Alpha, beta, gamma. You know that alpha, beta, gamma are products of radioactivity. Alpha, beta, gamma are products of radioactivity. Radioactivity means emission of particles or energy from unstable nuclei. Emission of particles or energy from unstable nuclei to become more stable. To become more stable. In the atomic world, in the nano world, energy and mass are not two different things. They are the same. If something has a higher mass, that means it has a higher energy. The higher the energy, the lesser the stability. The higher the energy, the lesser the stability. So, if certain nuclei have higher mass, certain nuclei have higher mass, they try to give out energy or particles to become more stable, to become lesser mass nuclei. So to do that, nucleus should break and give out particles or energy. So if the nucleus gives out, emit energy or particles, we call it radioactivity. We call it radioactivity. Okay, so the products of radioactivity are alpha, beta, and gamma. You know, alpha is helium nucleus. In other words, alpha is helium nucleus. Beta is electrons, no mass, -1 atomic number. Alpha helium nucleus, so atomic number 2, mass number 4. Gamma is just energy radiation, atomic number 0, mass number 0. Alpha, beta, gamma. Okay. What are the three things? This is the first exam point you should need. First point is about penetration power. Penetration. Penetration power, the only thing you should know is whether it is higher, medium, or lesser. So penetrating means, you know, it goes through a certain obstacle, the ability to go through certain obstacle. Alpha is the biggest particle here. So it has least penetration power. Beta has somewhat medium. Gamma has the highest penetration power. Why gamma has the highest penetration power? Gamma is electromagnetic radiation. Gamma is electromagnetic radiation. It's not a particle. So when it goes through an obstacle, it doesn't collide with any other. So it has a very high penetration power. That's it. No need to know any other definitions, like no need to know about that this can penetrate from 1 centimeter plate, like that. No need to know anything. Just a simple comparison. Which one has the least, which one has the highest power. That's it. It's penetrating power. It totally depends on the size of the particle. Number two, ionization power. You know what is ionization? Colliding with a compound, colliding with an atom, and releasing an electron from it, releasing electrons from it. So ionizing power increases, ionization power increases if it has a higher moment, if it has a higher moment. So if the particle is big, it has a more uh, effect, it can occur more effect on another particle in the collision. So ionizing power is highest in alpha because it's the biggest particle here. Its momentum is very high. Beta, again medium. Gamma has the least. Gamma is not even a particle. It's just electromagnetic radiation. Ionization power of gamma is least. Last but not least, the thing you should know is velocity. Velocity. Let's see in vacuum. Velocity in vacuum. That's the point we should know. Alpha, let's say, first let's go to gamma, because gamma is an electromagnetic radiation. You know, electromagnetic radiation show 3 into 10 to the power of 8. 3 into 10 to the power of 8 meters per second velocity in vacuum. And we take it as same as in air, but the real definition is for vacuum. So however, C is 3 to 10 power of 8 meters per second. It's the velocity of electromagnetic radiation. And you know, only gamma is electromagnetic radiation here. It shows C in vacuum or air, not in media, not in other media. In other media, velocity decreases. It's even in physics. And alpha beta. Beta is a much smaller particle. So it shows around 0.9 C, some say 0.99, and some say 0.95. And alpha particle, helium nucleus, without the 2 electrons, we call it nucleus, shows 0.5 C, some say 0.56. It doesn't matter. It doesn't matter. The only thing you should know is to compare. That's it. That's the first exam point. When you do exam points with me, take a small book, like 80 pages book, write down the topic, exam points, atomic models, then take it down. This is the first exam point you should know. With this exam point, even in physics and almost in chemistry, you will gain some marks, because all the questions are made based on these points. It doesn't matter what is the year. You will realize what I am saying when you do practice with this. This is what you should do. This is what the only thing you should do for A levels. Okay, that's about first one. Let's also go to the question. Ionizing power of alpha particle is greater than ionizing power of beta. Yes. Now we know that. We know why. It's bigger. The mass of alpha particle is very much greater than mass of beta. Yes. When both are correct, you know, there are two options, whether answer is 1 or 2. You know, 1 means Answer 1 means both correct. Second statement explains first statement. Answer 2 means both correct. Second statement doesn't explain first. Here, first, second explain. Second statement explains the first statement. So here answer is 1. Answer is 1. That is the point. That's the point. Okay. Like that, we finished first exam point. Let's go to another exam point. I'll delete it. Point 2. Question 2 gives us point 2. Which of the following statements are true? A. In a strong magnetic field, beta rays are attracted towards N magnetic pole. Okay, let's write down exam points before we do the question. First point is only charged particles deflect in electric or magnetic field. Only charged particles, electric or magnetic field. Only charged particles. No radiation, no uncharged particles. Only charged particles deflect in electric or magnetic field. Next point. In electric field, particle moves towards the opposite charged plate. Electric field, charged particle moves towards the opposite charge plate. Remember, it's towards, not onto. Towards, not onto. That's a very good point. Onto means if it is a negative particle, it should go to the negative side. Now, think that a positive charged particle goes and there are two plates to make an electric field, a positive plate and negative plate. So some students think that it goes onto the plate. No, it's wrong. It may or may not go onto the plate. It goes towards the plate. It goes towards the plate. Towards means like this. Towards, not onto. That's a very good point. Next point. In magnetic field, charged particle only deflects to a perpendicular direction, of magnetic field. You can use Fleming's left hand rule to detect the direction. Remember, in magnetic field generated from northern pole to southern pole. If there's a positive charged particle, it doesn't go towards NOS. It goes, magnetic field is from N to S. Positive charge particle goes in a perpendicular direction, not towards NOS, not like in an electric field. If you really want the direction, it's something under physics, but if you really want, where does this deflect? Which direction this deflects? Use Fleming's left hand rule. FBI, I think you can remember it. Thumb gives you force, index finger to magnetic field direction, middle finger to current. FBI, left hand rule. Keep 2-3 fingers perpendicular to each other. Positive particle direction can be taken as the direction of current. So magnetic field is top to bottom according to this plane, according to the screen. So FBI, if you put FBI, to which direction your thumb is there, which direction thumb shows. Thumb shows into the screen. So the force, when it is inside the field, force is into the screen. Force is into the screen. That means it's 3D. It goes into the screen like this. I can't show it in a two-dimensional plane. It's 3D. It goes like into the plane. It deflects into the plane like that, not to top, bottom, or left, right, into the plane. That's why I put it as cross. So that's the point. Another important point is, I'll erase this. Another important point is, here I'll put all the points you need. Deflection angle depends on size of the particle. The smaller the particle, the higher the deflection. This is more complex than this. We have to take charge density. But for now, for your A levels, no need to know about charge density for now. It's charge divided by radius. That's there, radius square. But for now, no need to know, because for these lessons, you only get alpha, beta, gamma. For this, thinking like this is totally enough. But in physics magnetic field, we will learn something bit advanced. Smaller the particle, higher the deflection. I'll show it. This is target question 2. Positive plate, negative plate. You give, there's a radioactive product. It gives out radiation. So, alpha, beta, gamma are going out. Gamma goes like this. Alpha will move like this. Wait. Alpha will move like this. Beta like this. Beta is smaller. Electron is very smaller than helium nucleus. So it shows a high deflection. Alpha goes towards negative plate. Still, the deflection is not that much. Gamma is not even a particle, so it doesn't deflect. It doesn't deflect. With that point, look, you can do any of these questions. Even for this year, the next year, after the next year, the same point repeats. In chemistry, in physics, same point repeats, question changes. If you know all the points in each lesson, you can mark more than 45 answers correct. That's the only method. That's the key. That's the key. Not theory, not any other. Do past paper questions. Get the practice with points and do it again and again. Take the points into it. Then you can think through the basics. That's the only way to get a very good pass. Okay, for an example, to show you the importance, let's do the second question. Which of the following statements are true? Strong magnetic field, be rays are attracted towards N. No, we know the point. It doesn't go to NOS. In a strong magnetic field, beta rays are attracted towards S magnetic pole. No, it's wrong. In electric field, alpha rays are repelled by the positively charged plate. Yes, that's correct. C is correct. In electric field, gamma rays are not attracted towards the negative. Yes, gamma rays are not even particles. They cannot be attracted by any other. So C and D are correct. Both A and B are wrong. A, B, B, C, C, D. C, D correct means answer is 3. Answer is 3. Okay. I'll do another 1 point for you, which will be repeated again and again. The third point we will learn is in the third question. It is about isotopes. Isotopes. I'll erase this. You should write this as the second point. This will help you a lot. Okay, let's move to third point, the last point in this small video, isotopes. You know, isotopes are nuclei, are having nuclei with different masses in same element. Having nuclei with different masses in same element. Should be same element. Masses, only masses are different. Actually, mass differentiation, mass is different due to the different number of neutrons, not protons, because atomic number remains the same. That's why we call it the same element. But masses change because the number of neutrons change. So for the question, have the same number of neutrons. Wrong isotopes. For an example, hydrogen has 3 isotopes. There are many other also. Protium, deuterium, tritium. 1, 1, 1, 2, 1, 3. You know atomic number is the same. That means number of protons in this is the same. In the mass number, there is proton number plus neutron number. So proton number is the same. Only difference is neutron number. Here, 1 proton, 1 neutron. Here, only 1 proton, no neutrons. Here, 1 proton, 2 neutrons. So atomic number is the same, but mass number is changed. These are called isotopes. Remember an extra point for your knowledge. In any element, the isotope with the highest mass is radioactive and unstable. It cannot hold that mass, so it's unstable. So the nucleus breaks down and gives out radiation, like chlorine 37, like carbon 14, carbon 14 dating, maybe you can remember it. They're unstable, so they are radioactive. Okay. However, this is isotopes. They have different number of neutrons. A wrong. Same number of protons, correct. Same number of electrons, yes, they are elements, so yes. Have same number of nucleons. Nucleons means proton number plus neutron number. Proton number plus neutron number. No, even though the proton number is same, neutron number varies. So no, nucleon number is different. Answer B and C. B and C means answer 2. This point will also help you. There are additional points that come to exam under isotopes. That point is, you can take down this. Isotopes show the same chemical properties, but their physical properties are different. Physical properties are different. Example for physical properties: mass, density, etc. Remember, this point will become again and again. Same chemical properties, because chemical properties totally depend on number of electrons. Number of electrons in isotopes is the same. Number of electrons in isotopes is the same. So chemical properties are the same, but masses are different. So physical properties are different. So very, very important point. Okay, so I did 3 points, and check the questions other than the theory parts, normal theory parts. These points are the things mostly help you in any lesson. I'll help you in more points in the future, and hope you will learn something from this. And always remember, do only questions with points. That's the only way to get a very good grade and be successful in this exam. Thank you very much.